Calculating probability using a Poisson approximation. Understanding statistical methods is essential for analyzing systems and predicting behaviors. One such method is calculating probability using a Poisson approximation. This study will guide you through the fundamentals of the Poisson distribution, its applications, and how to implement it in Python, complete with an example calculation. What is the Poisson distribution? The Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space. Provided these events occur with a known constant mean rate and independently of the time since the last event. Is particularly useful for modeling rare events. Key characteristics of the Poisson distribution. Discrete events. The Poisson distribution is used for countable events like the number of emails received in an hour. Mean rate, lambda, the average number of occurrences in the interval. Independence, the events are independent of each other. When to use Poisson approximation. Calculating probability using a Poisson approximation is particularly helpful in situations where the number of trials is large. The probability of success in each trial is small. Events occur independently. Common applications include modeling the number of phone calls received by a call center in an hour. Predicting the number of faults in a circuit over a specified time. The Poisson probability formula. The probability of observing k events in an interval can be calculated using the formula below, where px equals k equals probability of k events. E equals Euler's number, approximately equal to 2.71828. Lambda equals average number of events, mean. K equals actual number of events that occur. Example calculation. Let's consider a scenario where a network system experiences an average of 2 failures per week. We want to calculate the probability of observing exactly 3 failures in a week. Here, lambda equals 2 and k equals 3. Using the Poisson formula. Calculating this step by step. Calculate E2. E2 approximate 0.1353. Calculate 23 equals 8. Calculate 3 is not equal to 6. Substitute these values into the formula. Thus, the probability of observing exactly 3 failures in a week is approximately 0.1804 or 18.04%. Implementing Poisson approximation in Python. To facilitate calculations and automate the process, you can use Python. The scipy.stats library provides built-in functions to compute Poisson probabilities easily. Here's a simple Python script to calculate the probability of observing exactly k events. Output. When you run the script, it will display. Summatively, calculating probability using a Poisson approximation is a powerful tool in electrical and computer engineering, especially when dealing with rare events. By understanding the Poisson distribution and its applications, you can effectively analyze system behaviors and improve decision-making processes. For further reading, you may explore these scholarly sources. Poisson distribution, Wikipedia. Introduction to Probability, MIT OpenCourseware.